So first, who we are. We are Ford Motor Company, and we are a joint venture between Ford Motor Company US and Koç Holding Group in Turkey. So we are like sharing company between both of them. And we are automotive manufacturers, and let's say our employees are around 10K, so it's a huge, extremely huge company, and we are distributed to 3 factories only in Turkey, and 3 factories is extremely huge. And we have biggest R&D center in Turkey, which have 1.5K engineers are working there for even R&D and product development. Some brief about our products. Those are products which we have the IB of it. Even Ford-Otosan, like Ford Motor Company, have another IBs. And we have trucks, we have carriers, we have transit vehicles. Those are light commercial trucks. And that truck on the left here won the Truck of the Year in Europe last year. And we have like 7K unit per year for those huge trucks and almost 380K units per light commercial trucks. So let's get started. Why do we care about V2X here? Of course, V2X to ensure road safety and environmental aspect like pollution and reducing like fuel consumption, especially in platooning itself. But to do that, we have to make connectivity between vehicle and vehicle, and this is our major concern, and also some vehicle to infrastructure in order to organize that flow of the traffic. So distributing these signals between vehicle can be done through various connectivity, but again, why do we are looking to visible light communication to be utilized in vehicular connectivity? So now we don't have like connected vehicle. We have cooperative connected vehicle. In that case, we are controlling each vehicle through each others, not just to spread some signals between vehicles like CAM messages or DINAM messages, like cooperative awareness messages or distributed environmental messages. And here are the key points here of the V2X, which most of you are aware of it, like reduce energy, like caring about time management here in order to make like smooth traffic flow. And again, here like the ways of making connectivity through V2X, or even it's cellular or direct connectivity between vehicle and vehicle. And as a redundancy technique, we have visible light communication to conduct that. So, who we are. Here, we have lots of projects are going to vehicle connectivity. Let's start first with the first one, even making highway autonomous vehicle while trucks are moving or vehicles are moving, and even though while we are making changing borders between country and country, like smooth handover between operators in order to ensure connectivity at that time, and any drop of the message is going to make a big disaster. So ensuring that connectivity at handing over between companies is cross-border is one of the major tasks here. Another task is like autonomous truck or parking or autonomous, let's say, a terminal use for that, which means vehicle are on its own making its own decision according to the surrounding environment. So here you have to scan the environment, make like a bit mapping to the surrounding and connect to the vehicle, and the vehicle is going to make its decision. Same for construction site, as you can see here, like to ensure safety of the workers there. Any small, like some people are here are working in the construction company, in construction site, and at some times dusts are there, so you cannot see them. In that case, you can ensure connectivity between vehicle and pedestrian in order to ensure their lives. And of course, the best one is for ports or something in order to make autonomous vehicle there or autonomous routing. So again, the next video, shall we start it together? It is the same one, but we are going to illustrate here what exactly are we doing in order to initiate platooning. First, you are going to drive your car and you are going to look for a surrounding platooning in order to engage with the people here. So you just make a search for platooning and another vehicle found to make a platoon with. So you are going to couple connectivity between those vehicles. In that case, you are going to send a request and the other guy is going to accept it. And finally, if he accepts it, then you are going to remove your hand. In that case, the truck is going to steer in its own, and the distance is controlled according to the speed of the leader one. So actually, that guy now can sleep. So the distance here that we are using is 1.5 second distance. As long as you are accelerating, then the distance is going to vary. And what if someone just stops in front of the platoon again? That driver is going to stop because he's driving of the whole platoon, and the other one is going to stop autonomously. So another case, let's say, if someone just trying to interrupt the platoon here, and another vehicle just came at the intersection or the separation here, and tried to stop between those two trucks. In that case, like, we are controlling again the gap according to that separation, but that 1.5 second is going to be between each of those. Otherwise, that one is going to be crashed. So again here, the connectivity, it's about reliable communication link between vehicle in all of those different conditions. Otherwise, we are going to face lots of consequences. So that platooning even like a step to have full autonomous vehicle. Now the follower driver do some activities like initiating platooning, and the only leader one is leading the platoon itself. So what we were talking about here, it's SAE. SAE stands for Society of Automotive Engineers, and that one is controlling or identifying the level of autonomy of each truck. What we are using here is level 2. In that case, we are controlling the lateral control, the steering wheel, and acceleration and deceleration. This is level 2 autonomy. And our vision, our target is to achieve level 4, which is full autonomous vehicle. And again, it depends on connectivity. So here, in order to make a platooning, you have to use, like, first of all, perception, which is like you have to use the camera in order to make lane detection, in order to make lane centering, some radars in order to measure the gap between the trucks itself, and of course, some connectivity in order to transmit the connectivity or actions, what we're supposed to transmit between the leader and follower trucks in order to make actions at the follower trucks. And again, lateral end control and platooning manager in order to initiate the platooning at the beginning. And who is going to be leader, who is going to be follower? Can we exchange between that follower to become leader after some time? It's okay. It's about management, those platooning, and HMI like tablet in order to control all of those or make input methodologies. Again, the key point here. Why do we care about visible light communication? So visible light communication could be used here as a use case, as a redundant communication technique. You will not ever have a VLC-based platooning, because first you need to initiate a platooning, and in that case, you need to have if you are going to use visible light communication, you have to use if you are going to use a visible light communication platooning, cars must be standing like behind each other in order to initiate it. But with RF, you don't have to stand behind it. You just be in the range of RF, which means if you're going to use DSRC, you have to be in a radius of 300 meters, a radius of the antenna. In that case, initiating platooning must be done with RF. But while you are moving, you must have a robust link. In that way, visible light communication is going to play. So if you are transmitting light as a redundancy to visible light communication, as a redundancy to radio frequency, now you have two communication links. If one drop, you can survive with the other one. Not only that, if you are using here any RF technologies, you cannot support high applications, which means sometimes you need to transfer the video of the first leader, what's going in the road in front of him, to be transmitted to the other trucks. Otherwise, the driver is going to be boring. So you can see what's going on at the platooning leader from his camera. So I'm recording from his camera as a real-time video transmission. to be transmitted to the forward tracks. Not only that, I can just make inter-cabin communications between trucks, which means those drivers, because definitely the followers are going to be boring, so they are going to feel boring. So they can communicate with each other, like voice communication, video communication if they need.
Sorry, can I have a quick question?
Sure.
So audio, video, that's non-real time, not safety critical. If you talk about actually the important part, let's say the one of the link fails, the other one is used as a redundancy. Do you know the latency constraints that I have for, let's say, quickly handing over the data, managing the situation? Do I have tens of milliseconds, units of milliseconds, or maybe seconds?
Sure. For video transmission here, we are just using visible light. We are going to use visible light communication for video transmission. And for video transmission, we have 50 millisecond latency of each frame. Otherwise, bigger than that, you are going to have like delay between the video transmission, and it's not going to be the point. But for visible light, for track platooning itself, we have maximum 100 millisecond delay in low dense environment. In higher dense environment, it should be reduced to 50.
Okay.
This is according to the standard. It's a standard for track platooning. So of course, time latency here is critical. Yes.
So once I saw a talk and they were showing that the possibility of sending information from some camera in front of the on top of the first platoon back to the cars behind, and so this way you have a picture or a video of what's going on.
Exactly.
And so perhaps you can leave the platoon without waiting that some action is happening. I don't know. For some you can you see exactly what's going on. So I'm expecting that you may use this link also, not only for entertainment, for communication between the drivers, but also to provide image processing, video processing from this camera.
Exactly, yeah. So we are transmitting that video from the first one, just to have a real-time video of what's going in front of the leader one. So not even for entertainment. Entertainment is another way, because visible light communication has like extremely high bandwidths. So now we have a bandwidth, we are eager for some applications, extra applications. So what we've done as a practical case, we have one-way visible light communication as a hybrid connectivity here. So we have truck are communicating to truck with normal RF link, and now we employed visible light communication between the forward truck to the leader truck with visible light, just for platooning messages. Now we are going to have another link here, and in that case we are going to in that case we are going to have full visible light communication RF hybrid platooning. Okay, platooning is an easy case because two cars are following each other, but what if those cars make maneuvering or something? In that case, you have to define, or you have to install your photodetector, which is the most critical part, in the excellent position or the optimal position. So according to each use case, you should identify how many photodetectors you are going to need, what is the exact position in order to get optimal communication link in most of those use cases. So here we are making some simulations, and of course practical implementation for those simulations in order to have robust link while vehicles are maneuvering. So here, let's say, in some of maneuvering cases, which is supported by platooning, even changing lane, like have a curved road or something, 4 detectors at the back are fine. And those can be switched with selective combining technique between both of them. So at turn, let's say, if we have photodetector at the back, at turning, the back is going to be blocked, but the one at the edge is going to work. So once the signal is going to be interrupted, the other photodetector is going to survive. So making selection combining is the easiest way between both of them. And again, in order to have omnidirectional coverage, this is still unknown for us, but we're working on it. How many photodetectors? What are the positions of those? Still mystery. Okay, and finally, after we identify all those, we're going to have like a redundancy technique between our visible light communication and our radio frequency link in order to ensure system reliability. And finally, finally, we are going to work also on the hardware implementation by ENLIGHTEM projects. 2 ESRs are going to come to our company also in the scope of ENLIGHTEM project in order to work in the back-end developer of the hardware connectivity. So some of your colleagues are going to support us in that situation. Of course, all of you. And by here, thank you for listening and see you next